This lesson is on zero and negative exponents. The essential question of today's lesson is how can you evaluate a non-zero number with an exponent of 0? And also, how can you evaluate a non-zero number with a negative integer exponent? So what we're looking at here is we've got the quotient. This is the quotient of powers property. If you're looking at, you got 5 times 5 times 5 divided by 5 times 5 times 5. These all cancel out. And whenever you have any number divided by the same number, you're going to end up with 1. So remember, if we subtract, we get 3 minus 3, which is 0, which is 1. The next one would be the same. Your 6's would cancel out, and you'd have 1. And remember, if you have 6 with 2 minus 2, you've got 6 to the 0 power, which is going to be 1. If you continue doing these the same way, you'll still end up with all of your negative 3's canceling out. So you get negative 3 to the 0 power, which is still 1. And the same is going to be true for the negative 4 here. And all your negative 4's will cancel out. And if you subtract, 5 minus 5 gives you 0, which is negative 4 to the 0, which equals 1. Notice the pattern? Any number to the 0 power is going to be 1. So when we're looking at something like this, if you have 1 times 3 to the 4th, you're still going to have 3 to the 4th. 8 squared, remember 8 to the 0 is going to be 1, so you end up with 8 squared. Negative 2 cubed times negative 2 to the 0, which is just 1, is again still just negative 2, keep the parentheses, cubed. And 1 times negative 1/3 to the 5th power is still going to be negative 1/3 to the 5th power. So some of our key ideas that we have here is that zero exponents. For any non-zero number, a to the 0 is going to be 1. The power 0 to 0 is considered undefined. So whatever number you have, if it's to the 0 power, the number will always be a positive 1. Now, negative exponents, this is where it gets a little trickier. For any integer n and any non-zero number, a to the negative nth is the reciprocal of a to the n. That means you flip it upside down. So if you have a negative exponent, you put a 1 in the numerator and put the same base and change it to a positive exponent in the denominator. So looking at our examples here, we've got 3 to the negative 4th. Now remember, with these negative exponents, the definition of a negative exponent is you put a 1 in the numerator, and then you put 3 to the positive exponent in the denominator. Then you're going to evaluate the power. 3 to the 4th is 81, so 3 to the negative 4th is 1 over 81. So let's look at this on part B. Now we're multiplying times 1. So we're going to sit there and we're going to, according to the product of powers, we're going to add the exponents. So negative 8.5 to the negative 4th plus 4. Remember, negative 4 plus 4 is going to give us 0. So we've got negative 8.5 to 0. And remember, any number to the 0 power is going to be 1, which is the definition of a 0 exponent. So let's look at C here. We've got 2 to the 6th divide 2 to the 8th. Remember when we're dividing exponents according to the quotient property that we need to subtract the exponents. So 2 to the 6 minus 8. Now you just need to simplify 2 to the negative 2nd. But you never want to leave something with a negative exponent. So in order to simplify this further, remember we need to put 1 in the numerator and then put the base with a positive exponent in the denominator. That's the definition of a negative exponent. And then again, we can simplify. 2 squared is 4, so we know that the power would be 1 over 4. Now let's look at example 2, simplifying expressions. Now remember, well, according to our zero exponent rule, x to the 0 is just going to be 1. So you get negative 5 times 1, which is just simply negative 5. Now we get a little more complicated where we have a 9 in the numerator, and then y to the negative third over y to the fifth. Now, with that negative exponent, your base is just the y, not the 9 too. So to do that, we're going to look at the quotient of powers property. So you've got 9y to the negative 3 minus 5. Well, negative 3 minus 5 is going to give you negative 8. So you got 9y to the negative 8. But now, like I said, we don't want to keep a negative exponent. So according to the negative exponent rule, we put y to the 8th in the denominator. The only difference now is we already have a 9 in the numerator. So we're going to keep the 9 in the numerator and divide by y to the 8th. And that's as far as you can simplify, because we don't know what y is equal to. And that's the definition of a negative exponent. So how are you going to do that with a real-life application? A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? Well, the first thing you're going to have to do is convert hour to seconds. Because we know over here, it says a drop of water is 50 to the negative 2 liters. So we're going to convert 1 hour to seconds. So 1 hour times 60 minutes per hour times 60 seconds per minute. Notice how we can cross-simplify the terms. That's something that you hopefully have learned. But then, so the hours would cancel out and the minutes cancel out. So we're left with just seconds, which is what we want. That's a little bit of chemistry, which is called stoichiometry, just for your information. But we're going to take 60 times 60 seconds, which is going to be 3,600 seconds. Now, the water leaks from the faucet at a rate of 50 to the negative 2 liters per second. Simplify the time by the rate. So we're going to take that 360 seconds times the rate, which is 50 to the negative second liters per second. So, remember, according to our negative exponents, that's really 3,600 times 1 over 50 squared. So when we evaluate that power, we're going to get 3,600 times 1 over 2,500. When we multiply that, we end up with 3,600 divided by 2,500. And then when you simplify, you end up with 1 and 11/25, or 1.44 liters. So your conclusion is that 1.44 liters of water leak from the faucet in 1 hour. Now you've got an assignment on Clever. Make sure you show me your notes and then finish your assignment in Clever.